Hey, welcome back. In this video we are going to learn nucleophilic acyl substitution reaction of carboxylic acids. This is a new class of reaction that I mentioned in one of my previous videos when I talked for preparation of carboxylic acids and nitriles. We are going to see the comparison with nucleophilic addition that we learned to aldehydes and ketones and some of the reaction and the mechanism. Before we dive into this topic, you can feel free and follow me on the social media such as Instagram. That is this one here. Let's dive now to the nucleophilic acyl substitution reaction of carboxylic acids. We learned nucleophilic addition, and we start from an aldehyde or a ketone, we form an alkoxide, and after that protonation to yield an alcohol, or in case of the nitrogen we yield enamines and imines. In the case of nucleophilic acyl substitution, the difference between these two is that when the nucleophile attached to the carbon, sure it forms the alkoxide intermediate, but the epsilon here is a good leaving group and it goes away and you form the carbonyl with the nucleophile attached. We are going to see the main ones, the reactions of the main ones in the future videos. For now, let's focus to the relative reactivity of carboxylic acids derivatives. Acid halides are the fastest, are the most reactive one. After that comes anhydride, and after that comes esters. After that esters and amides. Those two are present in the living organism, but those others are not present because they react violently with water. We can go from here, as you can understand this scheme. So from the most reactive we can go to less reactive. The basic law of universe, from a higher energy state to a lower energy state, is spontaneously possible to go. Okay, main reaction. Main reaction that we are going to focus on the carboxylic acid derivatives are, when you have a carboxylic acid derivatives, the possibilities are hydrolysis reaction with water to yield carboxylic acids, alcoholysis to react with an alcohol to yield esters, aminolysis to react with an amine, primary or secondary, to yield amides. Reduction that we learned with lithium aluminum hydride to yield aldehydes or alcohols, primary alcohols. And the last one is Grignard reagent that you can yield ketones or alcohols. We are going to see all those reactions to each of those classes of carboxylic acid derivatives that you saw above. First, let's focus now to nucleophilic acyl substitution of the carboxylic acids. If a carboxylic acid is reacted with thionyl chloride, that makes the hydroxyl group a better leaving group. The analogy that we made to the reaction of secondary and primary alcohols to convert them to alkyl halides. In this case, this is going to give acid halide. So the final product is going to be this one. Conversion into acid anhydrides. It requires higher temperature and elimination of one molecule of water. Anhydrides, what are? Two carbonyl groups connected with one oxygen in the middle. So it requires two equivalent here. Right? Let's move further. Conversion into esters. First you react with the carboxylic acid with base to convert that to a salt, and after that through SN2 mechanism with primary halides preferable, you can form an ester. So because this is going to attack this one, this is going to go away. Right? Let's move further. At the point B, another way to convert carboxylic acid is through Fischer esterification. It works fine with simple alcohols and it requires acid catalysis. So it's going to be. Let's move further. Conversion into amide. You can react carboxylic acid with a primary amine or amine itself or secondary amine, and to yield amides. You have to be careful, you need to use this DCC. This structure here is dicyclocyclohexyl carbodiimide. You are going to yield an amide. Conversion into alcohols. we have seen this reaction even to the preparation of alcohols. So what we have, carboxylic acid treated with lithium aluminium hydride nether, and after that with H3O plus, is going to be converted to primary alcohols. The same thing can be done with boron trihydride and THF and H3O plus. Right to ethanol. Thank you so much for watching, and look forward to see you in the next video that is related with the reaction of acid halides and anhydrides. Up until there, peace.